Here's a little known but true fact about me. When I was in first grade, one night in my sleep, I was bitten by a bat, and that started me on my journey toward becoming Batman. Black. All important YouTube videos start with a black screen. And music. Edgy, scary music that would make a quarantined student nervous. And logos. Really long and dramatic logos. Warner Bros. Why not Warner Brothers? I don't know. DC. The house that Batman built. Yeah. What, Superman? Come at me, bro. I'm your kryptonite. I'm not sure what Rat Pack does, but that logo is macho. I dig it. Okay, get yourself ready for some math. If you stop at general math, you're only gonna make general math money. No, I said that. TMR, the math wizard, is very wise. I also have math skills and a 9-pack. Yeah, I've got an extra ab. Now, let's start the lesson. Number 2, 10.4 is about a thing called hyperbolas. So this is going to be almost the same as the ellipse lesson, but there will just be a few modifications. In terms of the definition of a hyperbola, it's a lot like the definition of an ellipse. The ellipse, you never had to memorize the definition, but the idea of an ellipse was any point on the ellipse, if you took two distances to the foci and added them, it was always the same. For hyperbolas, it's that we're subtracting distances to the foci. So for example, this point right here might be 4 from this and 20 from that. And if we subtracted 4 and 20, we come out with 16. This point here might be 3 from this and like 19 from that, but if we subtracted them, it would still be 16. Something like this might be 2 from this and 18 from that, but if we subtracted them, it would still be 16. That doesn't matter to your homework life, but that's just what's going on with this definition. We still have 2 points here called foci, and that's sort of like the determining points of these shapes. There's also going to be 2 vertices. But what's going to happen when we graph these today is you're going to end up with, for the ellipses, we had 4 dots, and we just made an ellipse out of them. Today, we're going to get 4 dots, and we're going to draw a box, just a dotted line box to help us serve as some guidelines. It's not part of the official shape the way the ellipse was the shape, but we're going to draw a box just to make some guidelines, and you'll see what I mean in a minute. Once we can make that box where the ellipse used to be, we're going to go dotted lines through corner to corner, and that's going to be one new word of the day called an asymptote. A-S-Y-M-P-T-O-T-E. An asymptote on a graph in math is just a line you don't touch or cross. It's just a guideline to try to stay within. So we're going to have some asymptotes today. But the hyperbola is going to have a u go this way and a u go that way. It's kind of like a double parabola. Parabola was the name of our u-shapes. We're going to have 2 u-shapes, each one called a branch, and that's going to be our shape. Differences on this compared to ellipses, when we do the foci today, we're going to add and root some numbers from fractions. When we did the ellipses recently, we subtracted and rooted. For the foci, we're going to add and root. The equations are different because the equations are all going to have a minus instead of a plus. So we get sort of an opposite sign issue going. Another difference we have is for the ellipses, the dominant number was always the bigger number to control the problem. For subtracting, for hyperbolas, the first number will take control of the problem. So if x is first, x is in charge. If y is first, y is in charge. And then the last thing that's new, when we go to do these asymptotes, the formula for doing the asymptotes will always be y equals. We'll always have a plus or minus. We'll always have a fraction. We'll always have an x. But when we fill in the fraction, we're going to do some kind of a y number on top of an x number, which kind of ties into the idea of slopes. Like we've had that formula before for slope, y's over x's, and y equals mx plus b, like that's where the slope should live next to the x. But the slope will always be a y number over an x number, but I'll refer back to that when it matters when we get to that other problem. So here's our first problem of the day. This isn't okay for the same reason it wouldn't have been okay a section ago. We need the problems to all equal 1. We need x squared and y squared to both be sitting on top of fractions. So if they don't give you the question that way, you'll have to do the same process. If this equals 144, divide everything by 144, that gets us a 1. 16 into 144 is a 9. 9 divided by 144 would be a 16. This question is going to be dominated by the x because the x is first. The first number will be the dominant number for the question. The center is the same thing we've been doing all chapter. The center will be at the origin unless you see parentheses. I see no parentheses, so the center is at the origin. Vertices, there are only going to be 2, not 4. The vertices are going to come from who's first. Since x is first, we're going to root this number just like we did for the ellipses. The root of 16 is a 4. X is first. So my vertex numbers would be 4, 0 and negative 4, 0. And I might as well graph while I'm doing this, I suppose. So center at the origin is here. Vertices of 4, 0 and negative 4, 0 are here and there. And while I'm looking at this equation, I should think about the same thing I would have thought about with ellipses. Y squared on top of 9, we would have done a root of 9 to have a 3. Y being 3 would be up 3, down 3. That is not going to appear in our list anymore. But when we go to do our graph, we are going to need to go up 3 and down 3. Not to make an ellipse, but to make a box like this. The up 3 was the highest the box will go. The down 3 is the lowest the box will go. The vertices are where the box is going to end, right and left. But we're going to go box instead of drawing an ellipse. And then I'm going to go corner to corner, drawing a dotted line that goes through corner to corner. That's one of the asymptotes. Here's a dotted line that is for the other asymptotes. I'll be back over there in a minute. To do the focus, we're going to add these numbers and root. Adding those is 25. Rooting 25 is 5. And since x was first, x dominates that question. 5, 0 is one focus. Negative 5, 0 is the other focus. So that's going to go here and there. Unlike the ellipses where the foci were always inside the shape, on this day, the foci will always be outside the box. If you ever get a focus inside the box, you made a mistake. Then for the asymptotes, it's always going to be y equals, it's always going to be plus or minus, it's always going to have a fraction, it's always going to have an x. I just need to grab y's number from here, the rooted version of it, which is 3. And I need to grab x's number from there, the rooted version of that is 4. To finish this graph, I just need to draw my 2 branches. The branch will always touch the vertex. It will always wrap around the focus. And as long as x is first, everything's going to be going right and left. So here was my vertex. I want to stay inside this asymptote guideline and stay inside that asymptote guideline, but I should be getting closer, closer, closer to it, as close as I can get without a touch. And it should have a wrap around the focus. So here I want to find the vertex, And I'm going to draw a U that wraps around the focus and gets super close to these lines, but does not touch them. And there is hyperbola number 1. Hyperbola number 2, almost the same, difference being y is first. So instead of everything going this way, it's going to be going that way. Y runs this problem. Again, you have to equal 1. You have to have fractions. If this is 400, I'm going to divide everything by 400. 16 dividing into 400 is 25. 25 dividing into 400 is 16. The equation has to look like this for us to do anything with it. Fractions and equaling 1. Y is first. So again, it'll be all y information over here. Center is the origin because I see no parentheses. Vertex based on who was first. Y, if we do the root of this, we're always looking to do the roots of everything to make our list of information. Y on a 16 gets me 4s and negative 4s, but I put those numbers second because they're y's. Y is running this problem. So I need to go up 4, there's a vertex. I need to go down 4, there's a vertex. While I'm doing that, I like to look at this fraction, and the x gives me 5s if I do the root. So I'm going to go right 5, I'm going to go left 5, but that's not really part of my graph, that's just helping me draw my guidelines. So I need a box that goes through the 4s and through the 5s. I need to go diagonally from corner to corner. These are my asymptotes. They should also go through the center. I miscounted that way. 1, 2, 3. I only did 4. Whoops, call it 5. Okay, so then we're ready to do the foci. To do the foci, we're always going to add and root. So 16 plus 25 is 41. If I try to do the root of 41, I really can't. Root of 41 is going to be the second number because y is second and y is running this problem. Y was first, so y is the box. To do those on the graph, I would need to root 41, which I'm feeling like is about 6.5. Let's see what the calculator says. Calculator says 6.4. So since y was first, it's up, down on this problem. I would need to go up 6 and not quite a half. I would need to go down 6 and not quite a half. And to make the graph, I need to find the vertex and then wrap around that focus. But I want to get close to these dotted asymptote lines. So this one's going to be pretty wide. We're getting closer, every closer, but not touching. Same on this. We want to get close, really close to the asymptotes, but don't touch them. And the two branches should be like wrapping around the focus. For the asymptotes, it's always y equals, it's always plus or minus, it's always a fraction, it's always an x. The fraction always has to do y's number, which was the 4, on top of x's number, which is the 5. We do the root of both of these numbers, and it's always y's on top of x's for the asymptote, regardless of who's bigger or who's first. 2 more, one harder one easier one. So the harder one, you're going to have to factor by completing the square again. That comes up every day, so that shouldn't shock you. So if I give you a nice long thing like this, your first move continues to be get the x's in a group, get the y's in a group. The x squared can't have anything on it. The y squared can't have anything on it. So for this x squared, I need to take off a 4. 4 into 24 is 6. And that leaves me a gap that I'll fill in later, and I'll have to pay for it. The minus has to come off of both of these, which switches this sign also, and leaves me a gap that I'm going to have to pay for later. To make our squares, this is x plus 3 squared, because I'm cutting in half. This would be y minus 2 squared, because I'm cutting in half. to pay for, or to do the missing link number, 3 times 3 is 9, that's always a plus. 9 times 4 is 36, so I need to add 36 to pay for that. 2 times 2 is 4, that's always a plus for our fill in the blank number. But this plus 4 has to be affected by this minus sign, and it's really a minus 4, so I pay for that with a minus 4. Add out negative 28, negative 4, positive 36, add that all up, it's 4, and we're almost done. We're not done until it equals 1. So I'm going to have to divide everything by 4s. The x plus 3 squared is over 4. The y minus 2 squared, oh, that's a lie, is over 1. Because if 4 divides into 4, that's 1. When this 1 divides by 4, that's a 4 on the bottom. This time I see parentheses, so the origin is not the center. The origin will be the opposite of these numbers, which is negative 3, and it is positive 2. So I'm going to go left 3, up 2, and there is the center of my graph. And then I'm going to highly suggest you again work through some kind of a rough draft list. The rough draft will guide you to the real answers. The rough draft will also guide you to the graph. I'm always going to graph from a combination of the equation and the rough draft. So vertices, my rough draft for the vertices, I'll always look to who's first. X is first. I root the 1. And I'm thinking 1, 0, and negative 1, 0. That is sending me then from the center, right 1 and left 1. I also have a y of 4 that I need to root the 4 to get a 2. That's going to tell me from the center to go up 2 and go down 2, which would land on the x-axis. And those locations are going to help me make my box. I'm not going to do the bottom of the box because I'm on the x-axis, but the top of the box would be 4 high because the center was 2 high. Asymptotes, little dotted corner to corner action. To do the foci will also be x numbers because x is first on this problem. Add those to 5 and root. The root of 5 is about 2.2. So what I should do is go right 2 from the center, right 2 squares and a little more. From the center, go left 2 squares and a little more. And then I'm ready to do my branches to get super close to the asymptotes but not touch them and wrap around the focus. Same thing over here. And then I'm ready to make my real deal list. So to make the list, as we did with the ellipses, the negative 3 being the first number should add to all the first numbers. Negative 3 adds on to 1. Negative 3 adds on to negative 1. Negative 3 adds on to a root. And that just looks like negative 3 adding a root. Negative 3 on a negative root, just look like that. And we do the same with the y, as the second number of 2 adds on to all these second numbers. When 2 adds on to a whole collection of zeros, you just get a whole collection of 2's. The asymptote has a minor change. Instead of the y, just a plain old y like we did on all the others. When the center moves, we don't do a plain old y. We do this thing that we can see is now the new y. We're going to take the whole y minus 2. Likewise, at the end, we aren't going to do a plain old x like we were doing. We're going to grab the x that we created and leave that in parentheses as an x plus 3. If you had the y in parentheses too, it wouldn't hurt you, but it's not necessary. Still an equal, still a plus or minus, still a fraction. The fraction is still y's number rooted, which is a 2, on top of x's number rooted, which is a 1. And I'm not going to leave that as 2 over 1. It's unnecessary to have 2 over 1 be there forever. I'm just going to make that a plain old 2. Then I have the easiest one for last. So I'll stroll over here, clear some board space, and be back with you in a minute. the last group, there'll be 17 to 20 problems in the homework. And we're 2 days of homework. We're odds a day, the first day to 20, we're evens the second day also to 20. But the last group, they're going to just give you an equation that looks like this. And there's no way you're going to make fractions and squares, and there's no square, no factor by completing the square way. You could make this look like the others. So what we're going to go on the last 4 problems today is just make a table. Okay? If x times y is 12, just think of numbers that can make 12. Like 12 times 1, or 6 times 2, or 4 times 3. Or the reverse of those, 3 times 4, 2 times 6, 1 times 12. Envision all of those like they're ordered pairs. Just graph those. So like 12, 1 is over 12 and up 1. There's also a 1, 12. 6, 2, and 2, 6. 3, 4, 4, 3. And you can see, here comes a U shape. The asymptotes are actually the axes. The lines that we're getting close to but are never going to touch are the x and y axes. But that's not done. That's not 2 branches. We always have 2 branches for these, 2 parabolas. So we have to think of other ways we could multiply to get 12. If you were here, we'd stumble over this for a minute, but somebody sooner or later would realize positives times positive makes positives, so do negatives times negatives. And we could get a repeat of those same numbers, but both of them being negative. So you get stuff like -1 and -12, -12 and -1. Or 2 with 6, or 6 with 2, or 4 with 3, or 3 with 4. And again, the axes, x and y axes themselves, are going to be the asymptotes. So if you have something like 12 that has a lot of times table choices, that's pretty easy. If I threw you something like 1, I can still catch even in the midst of the virus. If I threw you something like a 1, 1 times 1 wouldn't be very good to connect dots with. So you might have to do then things like 2s with halves, or 3s with thirds. Or if they threw you something like 5. 1 times 5 and 5 times 1 wouldn't be enough to play connect the dots with. You might have to do 2 with 2.5. And the reverse. 4 dots is probably enough. Okay, and then do the negative versions of those. But the last 4 problems, you're just going to do a table. No centers, no lists, no vertices, focus, none of that stuff. Just do a table to make a graph, and we're working on that on 441, spilling into 442. First 16, you need the list, center, focus, vertex, asymptote, graph. But the last 4, just table and graph would be good enough for me. So, email me if you have questions.